this video, I'm going to show you the building science principle that we use for Cedar Residence that turned this project into a high-performance home. There are no rocket science or expensive smart home upgrade. They're really just fundamental, pure physics that can be applied to any project. First, we have to talk about what are we working with, the site. The Cedar Residence is located in Maine. It is a climate zone 6. That means we have long, humid winter and short and rather hot summer. In climate zone 6, we have about 7,000 to 9,000 heating degree days, which is a unit to calculate how many times in a year we need the heating system. So this means we will need a constant heating for most time of the year. Principle number 1, taking advantage of the sun. So the project is located in the northern hemisphere. So that means our sun comes from the south. So in the layout of the Cedar Residence, we'll position most of the living space and the primary bedroom facing the south, where we can bring the sunlight and the warmth from the sun into the house. In the living room, we also designed a large covered deck right at the sliding door facing the south. So in the summer, the covered deck can shade off the summer heat from the sun, and then in the winter, it will allow the low altitude sunlight to come in from the house. In addition to taking advantage of the sun from the south side, we also have to eliminate the glazing on the north side. Why is that? Imagine sitting next to a window in a cold winter day, where this window is facing north, and you can really feel the cold coming through the window, and our body is actually losing heat through the radiation towards the window. So this is why we also have to reduce the amount of window on the north side. And luckily for the layout of Cedar Residence, the north side is where the street side is. So we place all the auxiliary program like mudroom, laundry, and guest room into the north side where we can have smaller windows, at the same time providing the privacy for the residents. I'm Chloe, the principal of Design with Frank, and in our YouTube channel, we are looking to bring you the beauty of architecture and house design with the analytical and science perspective. In the same concept of radiation, that brings us to our second topic, thermal mass. Cedar Residence, we are using a slab-on-grade foundation that is fully wrapped with insulation. So the slab-on-grade foundation work as, yes, foundation, but at the same time, what we call it thermal mass. Think of a concept of thermal mass as like a battery for heat, where it can absorb the energy, hold it, and then slowly releasing it back to the environment. We have this warm concrete floor, and in the winter, the sun comes from the south with radiation will warm up the floor where it absorbs the heat. At nighttime, when the air cools down, the energy of the slab slowly releasing it back to the air. That allows the temperature swing inside the building envelope much more steadier rather than more drastic change. So to further enhance this effect, we embed the radiant floor heating inside the concrete slab. So radiant floor heats are basically tubes with hot water running through it that heat up the slab and turn the slab into a really warm, solid surface beneath us. And then that slab warms us, our body and the space in two ways. One, like radiation, where our body sees the surface of the slab and the heat can transfer between the slab and our body through radiation. It's this magical effect that the light can transfer energy without air. The second way it heats up is that the warm slabs heats up the air that's on the ground and then slowly rise up, so that also heats up the air around us. So unlike a forced air system where it heats up the air only and stratifies at the top, the radiant floor heat really warms us from below and continuously brings us this warming comfort. So having a radiant floor heat, it actually allows us to set the temperature a bit lower while still feels really comfortable. So in a way, it creates a much more efficient way to heat the house. In this video, all the footages you see of the drawings are powered by a software called Cedar Studio. It is a software that we built internally and we've been using it for a long time. We feel that it's a great software that we wanted to share to more building professionals. It is a 2D PDF drawing review software. So if you are a builder or architect or designer looking at my video, looking for a very powerful way to see your drawing, whether it's on your iPhone, iPad, computer, or collaborate with your team member, your builder, your consultant, Dita is a great way to do it. So I also hope you like the demo that we embedded into this YouTube video to show you how we can looking at building detail for construction plan in this seamless experience. Please check out the software, Dita Studio. I sponsor myself. So now we talk about how do we heat the house, how do we bring in the heat, how do we warm the house. We have talked about how do we keep the heat. Imagine one side you have this burning fireplace, warms you, on the other side you have this window blasting cold winds towards you. It won't work. It cancel each other out. So this brings us the principle number 3. We call it eliminate the thermal bridging. So the house surrounds us, the shelf that surrounds us, all the walls, the roof, and the slab. It's like a clothes in our human body. But we know that if there's a hole in our clothes, our body will feel the hot, all the cool that's coming from the outside. So in our wall assembly, most of the time we have insulation between the stud, which is great, but the stud itself only has about R1 per inch. Woods, they are not great insulator. So this is why every 16-inch, we created what we call thermal bridging. We have to block it. So for Cedar Residence, we have a 3-inch EPS foam on the outside for exterior insulation. And we use this product called nailing base, which is like a 3-inch EPS foam plus a OSB on the outside. The reason we need that because the cedar shingle needs a surface to nail. So having the insulation between the stud plus the exterior wall insulation, in total our wall has about R33. And then continues from the wall to the up, we have a roof. And the roof we use a raised heel truss system, meaning the bottom heel of the truss is raised. We have about 18-inch raised heel so that we can have the insulation continues in the same thickness from the wall to the top. Versus a lot of houses we seen, like a lot of old house, we use the regular truss where the triangle really thims down. So there's not much insulation right at the edge of the roof eave. So this is why we use a raised heel. And then below we have the force protective slab system where we have insulation also around the slab. So continuously looking at the building section, we have this entire blanket really wrapping around the house to keep all the energy, whether it's the cool energy or the hot energy inside the house. While having this continuous insulation is great, it also brings us a very interesting point. Those newer houses using the system, it creates a really tight building envelope. So in a cold climate in the winter, we don't want to open up the window to bring the fresh air. So most of the houses we live in is quite drafty. Like the house I live in right now is very drafty. So you don't really need to open up the window to get air since there's all sorts of places where the air will leak in. But it's not the case for Cedar Residence for this type of home. So we have to bring in fresh air in without opening the window. So this is what we install an ERV system. So this brings us to rule number 4, ventilation. So now we have beautiful warm air, wonderful environment on the inside, but we also need fresh air without bringing in the cold air from the outside or the hot air from the outside. So we use a system called HRV. There are 2 types. One's a HRV, one's an ERV. HRV means heat recovery and ERV means energy recovery. Means not only recover the heat but also the humidity. So for Cedar Residence, we have this system where bringing in the fresh air from the outside, not through the crack of the building where there might be dust or glue, but really from a delicate tube that's sucking fresh air from the outside. And then another tube sucking the steel and the old air from the inside out. And then where the fresh air and the old air inside the house meet, there's an interface, a machine that transfers the heat from the inner space to the outer fresh air. So in the winter, it transfers the heat of the indoor air to the outdoor air. And it works really well. Most of the time, you can recover about 60% of the energy. So the heating system inside the house doesn't need to reheat the air again, and again. This brings a much more efficient heating system. ERV system and HRV system is great. And whether you use a ERV or HRV is really depending on your climate and how much humidity you will need to control for your indoor environment. And let's go to the utility room. Kenny will show us all the machine, the radiant floor heat, the ERV that is running in the utility room. Nice. Okay.
All right. So this is a utility room, pretty tight. It's got everything in here. This is fresh air exchange, brink system. And up there, all the ductwork that go out to the house. And over here is fresh air coming in from the outside and then exhausting to the outside. These are two pressure tanks. This house was built on an old site and there was an original spring that was built in the 1800s. Here is the Norair heat pump boiler. The whole house has radiant in the floor. Basically, we've got a Turbomax connected to the heat pump. This is for domestic hot water. So the heat pump makes the slab warm and it also heats the water for showers. This radiant system just happens to have glycol in it. The glycol is essentially antifreeze. Glycol goes through the floor and inside here is a coil, and the glycol is inside the coil, and that glycol heats a jacket of water, and that water goes out to sink in the shower and all that kind of stuff. Up there is a little fresh air and intake because it's convex. There's also a heat pump system in the attic that has ductwork that goes to, I think, at least 3 or 4 rooms. Sort of go up through that door, but there's a kind of big space that you could crawl around and access the heat pump that's in the attic. And then we have a huge layer of insulation on top of that room. So when you go up in here, you're still technically in the conditioned space of the house. So that heat pump and all the ducts are really well insulated. Most of it is inside the conditioned house.
Thank you for your time, and I hope you like this video. I have many more ideas from HVAC building assembly to design. Please comment below of the topic that you want to hear more about, and we will try our best to make more videos and answer more of your questions. And please subscribe my channel, and thank you so much. Thank you for your time.